Welcome to Calculus Lecture 7. This is Derivation Rules Part 2. Today we're going to talk about derivatives of sine and cosine, the product rule, and the quotient rule. Okay, so these are some very valuable rules for deriving functions. All right, so we're going to build on top of what we saw last time, which was the power rule, the constant multiplier rule, sum and difference rule, and the derivatives of exponential functions. All right, to start off with, right here, we've got the derivatives of sine and cosine. The derivative with respect to x of sine of x is simply cosine of x. Okay, so we switch from one to the other. And the derivative with respect to x of cosine of x is negative sine x. Okay, so this negative sign is really important. So it's not a simple switching back and forth. We are also going from positive to negative when we take the derivative of cosine. All right, so let's look at an example. We've got y is equal to 2 times sine of x. By constant multiplier rule, we can bring that 2 out front, and we take the derivative of sine of x directly. So that just comes out to 2 times cosine of x. Okay, pretty straightforward. Similar kind of deal if we had y is equal to 1/2 sine x. Well, the 1/2 is just a constant multiplier. And you might see this in a different form, written as sine x over 2. It's the same idea. We can just bring that 2 from the denominator out as a constant in the front. Okay, so y prime is going to be 1/2 times the derivative of sine x, which is, again, cosine x. So just 1/2 cosine x. Example C. Now we've got a sum between x and cosine of x. According to our sum rule, we're going to take the derivatives of each component individually and just add them together. The derivative of x to the first power, as we know, is just 1. The derivative of cosine x, as we had just seen, is negative sine of x. So 1 minus sine x. And finally, something that looks a little bit more complicated is the function y is equal to cosine x minus pi over 3 times sine x. Okay, so to start off with, we use our difference rule for derivatives. We're going to take the derivative of the first part. Derivative of cosine x is, again, negative sine x. For the second part, treat this constant as something that comes outside of the derivative, and the derivative of sine of x should just be cosine x. Okay? So that cosine becomes a negative sine x. That negative you can just keep with that pi over 3. Derivative of sine x is just cosine x. Okay, so these are just derivatives of sine and cosine, and they're pretty straightforward. Now let's suppose we had to find the equation of the tangent line to the following function. G of x is equal to x squared plus 2 cosine x at the given value for x, which is pi over 2. Okay? So let's think about what elements we need here. So the tangent line is going to be passing through this point, pi over 2, comma, g of pi over 2, right? So pi over 2 is our x. We get the y value, or the y coordinate for this point, from plugging in pi over 2 into our original function, g of x. And the slope of this tangent line is going to be given by g prime of x evaluated at pi over 2. Okay, so just a review of what we've done so far. Now let's put it all together. So first off, let's find g of pi over 2. We're just plugging it straight into our original function. So we get pi over 2 squared plus 2 cosine pi over 2. We simplify that, we get pi squared over 4. Cosine of pi over 2 is 0. So this entire thing just reduces to pi squared over 4. This is the y coordinate, the y point, that goes with the x value of pi over 2. Okay, our next step, find g prime of x. Now let's go ahead and we take the derivative, and we can use our new trig rules for finding derivatives. Okay, so we're going to apply the derivative with respect to x to this entire function. This is a sum, which means we will take the derivative of each component individually, and then we will add them together according to our sum rule. So the derivative of the first part, we're just going to be using power rule. So again, that exponent just comes down in the front, and then we subtract 1 from whatever it was to begin with. So that part is just going to become 2x. And for the second part, again, we can bring our constant out front and then take the derivative of cosine x directly. The derivative of cosine of x, as we've just seen, is going to be negative sine x. Okay? So you just put these together, and we're going to get 2x minus 2 times sine of x. All right? Next step, we need to find g prime at pi over 2. So now we've got our general function for the derivative, which is going to give us the slope at any x value, but we want to find it specifically at pi over 2. So we just go ahead, we plug in pi over 2 for x. 2 times pi over 2 minus 2 sine pi over 2. This is going to simplify to pi minus 2. This is the same thing as our n. Okay, so these 2's cancel. Sine of pi over 2 is just 1, and that 2 remains. Now, our last step, let's put it together using the point-slope form. Okay, so this will give us the equation of our tangent line. So let's plug in each component. We've got y1, we've got m, and x1. y1, as we've seen before, is just pi squared over 4. M, as we just found, is pi minus 2. And our x value that was given was pi over 2. Okay, so this is our tangent line. Next, we're going to talk about one of the more important rules for derivation as well. So power rule is a really common one. Product rule is going to be very powerful and very useful as well. So this is when we're going to try to take the derivative of a product of two functions. And it turns out that the product of two differentiable functions, f and g, is itself differentiable. Okay, and it's going to be differentiable according to this law. So the derivative with respect to x of f of x times g of x is going to be f prime of x, so the derivative of the first function, times the original second function, plus the original first function, f of x, times g prime of x, which is the derivative of the second function. Okay, so we're kind of mixing and matching. We're taking the derivative of the first one, pairing it with the original second one. Take the original first one, pair it with the derivative of the second one. Okay, so just written out in kind of in English, the derivative of the product of two functions is the derivative of the first function in yellow times the second function in blue, plus the derivative of the second function in green times the first function in red. So let's take a look at an example, see how this is going to work. Let h of x equal 3x minus 2x squared in parentheses, so this is the one we're going to call our first function, times 5 plus 4x. This is our second function, g of x. Okay, let's find the derivative of h prime of x. Okay, so all I'm doing there is just identifying these. And now I think for these sorts of problems, it's really helpful to just write out everything on the side, right? So first of all, f of x is 3x minus 2x squared, meaning its derivative, let's just take that by itself on the side, f prime of x is going to be 3, because x to the first power, its derivative is just 1, so 3 times 1 is just going to be 3, minus 4x, so that 4x is coming from power rule. That 2 comes down, multiplies by the negative 2 that was already there, that's negative 4, and this exponent becomes 2 minus 1, which is just 1. So we get 3 minus 4x. Do the same thing for g of x. And g of x is 5 plus 4x. Well, derivative of a constant is 0, that's gone. And same deal here, when we've got x to the first power, that x just becomes a 1, the coefficient remains. So g prime of x is just 4. Now, we're going to put it together in product rule fashion, okay, according to our formula. So f prime of x is 3 minus 4x. G of x is 5 plus 4x. F of x itself is 3x minus 2x squared. And g prime of x is just 4. Okay, so we can go ahead and we can FOIL the first two functions. Go ahead and distribute this 4 over here. We're going to get 15 minus 8x minus 16x squared plus 12x minus 8x squared. Combine like terms, and you're going to get 15 minus 20x minus 24x squared. All right, so that's the product rule. As long as we follow this sort of format, it's a pretty straightforward. And I recommend everybody write it out like this, so it's very easy to reference, and you're not taking derivatives in the middle of plugging in all these different functions. Okay, so that's if we have a product. What if we have a quotient of two functions? Okay, so it turns out we can do something very similar. So the quotient of two differentiable functions is also differentiable, and this follows a similar formula, but it's a little bit different. Okay, so now we've got f of x in the numerator, g of x in the denominator. That's our second function. This is going to become a quotient as well, a fraction. Now, the numerator looks a lot like what we had in product rule. Okay, so we had f prime of x times g of x, f of x times g prime of x. But now, instead of a plus sign in the middle, this is a minus sign. It's a subtraction, right? And this is the one where order is going to really matter. So in product rule, you could have actually swapped that second product with the first product. But here, they do need to be in this order. So I recommend just getting used to this order and using it for both. And then just for quotient rule, make this a negative. For a product rule, just keep that as a plus sign. Okay, so f prime of x times g of x minus f of x times g prime of x, all of it over g of x squared. So whatever your original denominator was, it's staying there and it's getting squared. And this is going to work so long as g of x is not equal to 0. All right. So restated in English, the derivative of the quotient of two functions is simply the derivative of the numerator over here, f prime of x, times the denominator function minus the derivative of the denominator times the numerator function, all of it divided by the denominator squared. So let's see an example of this in action. So let's suppose we want to derive this function y is equal to 5x minus 2 over x squared plus 1. Right away we go ahead, we identify f of x as the numerator, g of x as the denominator. Okay, we write them out, and we're going to take the derivatives of each one. So the derivative of 5x minus 2, we already know, x to the first power, that x is going to disappear. We'll be left with just the coefficient 5. As for that negative 2, well, the derivative of a constant is just 0. For g of x, we've got x squared plus 1. We take the derivative of x squared according to the power rule. The 2 comes down. That exponent becomes a 1, 2 minus 1. Okay? And the derivative of that constant 1 is gone. It's 0. Okay, so now we've got our 4 functions of interest. Now we put them together in quotient rule fashion. Okay? So the exact same formula, same order. Let's go ahead and see how this looks. F prime of x is 5. G of x is our original denominator, x squared plus 1. F of x is 5x minus 2. G prime of x we just found was 2x. And then we don't forget, g of x has to also go into the denominator, x squared plus 1. And we have to make sure it's squared, as according to the formula. Okay, we go ahead, we distribute up top, 5x squared plus 5. We're just going to distribute that 2x first. So we get 10x squared minus 4x. We don't need to expand the bottom. There's not much math to do there. Sometimes there may be if we can simplify, but for now there's no real point. So we just simplify the top, distribute the negative sign, and combine like terms. We get negative 5x squared plus 4x plus 5, all of it over x squared plus 1 squared. Okay, so that's the quotient rule. So today we've covered derivatives of sine and cosine, derivative using the product rule, and derivative using the quotient rule. All right, and that's it. So if you found this lecture helpful, please again give it a like and subscribe so you don't miss the next one. Thank you for watching.